Good day to you all viewers. You're welcome to this video. Actually, you're welcome to the first part of this series. In this video, we're going to be seeing some practice problems under the concept of set. Okay, this question says, explain and give an example in tabular form for each of the following, which are these. Number one, or I, members or elements of a set, equality of a set, and power set. So we should explain these three things and we should also give examples of these three things, but we should do that in a tabular form. So the answer to those things are what I attempt to explain here. Alright. Now, first of all, I want you to understand that member of a set, member or element of a set, equality of a set, and power set of a set, these three things are one of the properties of a set. Of course, there are many other properties of a set, like modulus of a set, cardinality of a set, union of set, intersection of set. But in this particular question, the question says we should just explain and give examples of just these three in a tabular form. So first, member or element of a set. First of all, which is this? So members is either say member of a set or also known as elements of a set. It simply means these are distinct objects that a set contains. Alright, so those distinct objects that a set contains is regarded as members of a set or elements of a set. For example, if I have set A and this set A is made up of elements like 2, 4, 6. Good. Now, if set A has elements 2, 4, and 6, I can say that 2 is an element of set A, 4 is an element of set A, as well as 6 element of set A. If I don't want to use the word element, I can as well use the word members. Therefore, for me to say that 2 is an element of A, if I want to represent it mathematically, it will be that 2 is an element of A. This is how we represent it. Or we can as well say that 4 is an element of A. And again, 6 is an element of A. So this is how we represent it. So now in this case now we've defined what members or elements of a set is, and we've given example that this is set A, which is this, and 2 is an element of A, 4 is an element of A, 6 is also an element of A. Second one, equality of a set. Now talking about equality of a set, okay, let me just read what I have. Two sets are said to be equal if they have the same cardinality and exactly the same elements. Now, we've already understood what we mean by elements now, but what do we mean when we say cardinality? Of course, another name for cardinality is also modulus or magnitude. So, two sets, say set A and set B, will be said to be equal if they have the same cardinality. That is, if they have the same number of elements and again, exactly the same element. Take for instance, if I have, okay, let me just give an example. For example now, if set A is equal to 2, 4, 6, and set B is equal to 4, 2, and 6, now you will agree with me that these two sets now, they have the same element. In other words, this set A has 3 elements, 1, 2, 3. It has 3 elements inside of it. And set B has 3 elements again inside of it. Now, these two sets are said to be equal, number one, because they have the same cardinality. That is, they have the same number of elements. That is what we mean by cardinality. And the second criterion is that they have exactly the same element, meaning that in set A there is 2 and there is also 2 in set B. In set A there is 4 and there is 4 in set B. In set A there is 6 and also there is 6 in set B. So if two sets are made up of the same, exactly the same elements or exactly the same members, and again they have the same number of elements, that is cardinality, those sets are said to be equal. So that is what we mean by equality of a set. So finally, power set. Now, what do we mean by power set of a set? Like I have here said, this is defined as the number of possible arrangements that can be obtained with a given set. Simple. So, for instance, now if you have a given set, you can be asked to find the power set of that set given to you. So, the power set of that set will simply be the number of possible arrangements you are going to obtain with that set given to you. For instance, there is no space. Let me just write the example of this power set over here. Now, using set A again as a case study, remember that set A is 2, 4, 6. So this is set A. Now, if I want to find the power set of this set A, it will be P of A equal to 2 raised to power 3. Now, this P means power set of A. So PA, power set of A. Alright, P sub A, power set of A is equal to 2 raised to power 3. Actually, the formula for getting power set, which is power set, is actually 2 raised to power n, where n is the modulus or the cardinality of the set in question. So now the set I'm considering in this power set now is set A, which is 2, 4, 6. And the modulus or the cardinality of this set A is nothing but 3. That is why using this formula, I now have that power set of A is equal to 2 raised to power 3. And 2 raised to power 3 mathematically is nothing but 8. So very important. So what it means is that according to this now, this 8 means that this set A, which is set of 2, 4, 6, can be arranged in 8 different ways. So let me quickly do that. Therefore, set A, which is this, can be arranged this way. Set of 2 close, set of 4 close, set of 6 close, set of 2 comma 4 close, set of 2 comma 6 close, then set of 2 4 6 close, 1 2 3 4 5 6. Next one is set of 2 and okay, this is 2 4 6, 2 and 4, 2 and 6. Next one should be 4 and 6. The next one should be empty set. Okay, so what this is now, this is more like this is the example of what I should have here. So the power set of a set is talking about the possible ways in which the given set can be arranged. Now, in example, let's set A, which is this, let it be the given set. So it means that this set A can be arranged in these ways, all right? Because we need to apply this formula to get what the power set will be. So the power set is nothing but 8. Therefore, arranging it in 8 different ways, I should have this, all right? So let me attempt to explain this once again. So the set A is going to be when 2 is standing alone, when 4 is standing alone. So if 2 stands alone, I have here, 4 standing alone, I have this, 6 standing alone, I have this. Now 2 and 4, I have this. 2 and 6, I have this. Now 4 and 6, I should have this. Now 2, 4, 6 standing together, I should have this. Then when nothing is standing, I should have this. So of course, in arranging sets, in the case of power sets, we will always have empty set or no set. All right. So this is it with this particular question. So please stay tuned in this video. We're still going to see the second question under this. All right. This is the second part of the question. All right. So this second question says, explain and give an example in the set builder form for each of the following: complement of a set, equivalent of a set, difference of sets, or relative complement of a set. Again, these three things you see here is also a property of a set. Remember, I told you in the previous question that there are many examples of, or maybe there are many properties of a set. So this is it. Now, but we are asked to explain these three things and again give their examples in a set builder form. So it would have been a lot easier if we were asked to give their examples in a listing method. And of course, I've already made a video on how to represent sets in a listing method and again in a set builder method. So please do well to visit that video. Very important. Okay, so now what is complement of a set? So let us explain what this complement of a set is and now be able to give their example. Very important. So complement of a set is defined as a set of elements that is not in a given set but are in a universal set. So it means that whenever you want to get complement of a set, you must first, or maybe whenever you are given two sets, such that one is a universal set and the other one is the maybe set A, for instance, and you can be asked to get the complement of set A. So complement of set A will be those elements that are in the universal set but they are not in the given set, say set A. So, like I have here, since they said in the set builder method, example, let U represent the universal set. Alright, so is if U is a universal set such that U is set of X such that X is an element of natural numbers. Alright, so please do well to visit that my video on set builder method, that is set representation. It will help you. So this is the universal set given to me here now, and another set A is given. A is set of X such that X is even numbers. Very important. So now, if this is the set U, now I'm more like bringing, because I've already explained what they asked me to explain. Now I'm trying to use set builder method or set builder form to give my examples. All right. So if this is set U, which is set of all natural numbers, and this is set A, which is set of all even numbers. Now A complement will be what? So therefore, A complement, which is written as A superscript small c, and of course, most times it is also written as A prime. So whenever you see A raised to power C or A prime, both of them means the same thing. So it means A complement. So the complement of this set now, that is A complement, will be those sets that are, maybe those elements that are in this universal set, but they are not in the given set A. So what do you think those things will be? Now, and of course, natural numbers are numbers on the number line that excludes 0, and of course excludes all the negative values. So now when you talk about natural numbers, it simply starts from 1, 2, 3, 4 down to positive infinity. Now in the from 1 to positive infinity, there are even numbers there are odd numbers there. Now, if I want to write out the sets that are in here but are not here, it means that I'm going to write out only the odd numbers, and I'm going to avoid the even numbers. Therefore, A complement is going to be set of X such that X is what? Odd numbers. Alright, so this is the example of this complement of a set in a set builder method. Please take that down, very, very important. Now the second one says equivalent of a set. Now remember, in the previous question, that is question number 1, we saw equality of a set. We said that for two sets to be equal, it means that they will have the same element or the same member, and again they will be of the same cardinality. So that is it. Now, when we talk about equivalence of a set, it is similar to equality of a set, but they are not the same. In the equivalence of a set, they must have the same cardinality. That means they must have the same number of member. That is, their members will be the same, but they will not have exactly the same members. Very, very important we understand that. So, which example now? And of course, we are asked to use set builder method to give an example here. So, what it means that now, example over here. The example I'm going to give here is that A is a set of even numbers. For instance, A is set of X such that X is even numbers. Alright, now, and of course, the equivalence of this set is going to be maybe another set, and let me give a condition here, or let me just clean up this part. Okay, even numbers. Let me write it in short way. Okay, and these even numbers ranges from 2 to 10. Okay, so A is set of S such that S is even numbers ranging from 2 to 10. That is what it means. Now, let another set B, rather, let set B be set of S such that S is set of odd numbers. Now, and these odd numbers will actually range from 1 to 9. Now, if you watch carefully, even numbers from 2 to 10 is actually how many? It's actually 5. 2, 4, 6, 8, 10. So it's actually 5 numbers. Alright? And of course, odd numbers from 1 to 9 is still 5 numbers. So if you check carefully, set A. Now, if I'm to write out these things I don't know, if I'm to write out set A now in a listing method, you find out that A is equal to 2, 4, 6, 8, 10. Very important. And again, if I'm to write out set B in a listing method again, you find that B is equal to 1, 3, 5, 9. 1, 3, 5, 7, 9. Yes. Alright, so this is the listing method of this set A, and this is the listing method of this set B. So if you want set A and set B, you find that they have the same cardinality or the same modulus, but they do not have the same or maybe exactly the same elements or members. So because these two sets has the same cardinality or modulus, both of them are equivalent. Alright, so equivalent sets are sets that have exactly or maybe that have the same cardinality but not exactly the same elements. Yes. So this is a good example. These two sets now are equivalent to each other, and of course I gave their examples in the set builder method. But it would have been a little or maybe a lot more clearer if they said that we should give their example in a listing method just like this. But of course, I think the question is testing our ability to represent sets in a set builder notation and again in a listing notation. So please, like I said, do well to revisit that videos that I've made. Okay, so that is it for question for this equivalent of a set. What about relative complement of a set? And of course, this relative complement of a set is also known as difference of sets. Very, very important. So let's look at the statement I have here. For any two sets, A and B, for instance, for any two sets A and B, the difference of A and B, denoted by A minus B, is a set containing those elements that are in set A but not in set B. Very, very important. So if you are given set A and you are given set B and you are asked to take their differences, it means that the set that you are going to obtain will be elements in A but not in B. Okay, let me just try to give an example. And of course, this example is going to be in a set builder notation. Okay, so now in this case, if this is the case, it means that A, example, means that A minus B will be equal to set of X such that X is an element of natural number. Okay, let me not use natural number here. Okay, A minus B is going to be set of S such that X is going to be element of A and X is not an element of B. This is how we present it, alright? So this is just the example in a set builder notation. So when you talk about relative complement of a set, it's talking about, it means that the difference between these two sets like this is going to be the elements, or maybe your answer is going to be elements in A but not elements in B. For instance, again, let me give another example. What if it is B minus A in this case? Now, it will be this answer if it is A minus B, but if it is B minus A, the answer is going to be X such that X is an element of B and X is not an element of A. Very important. Of course, whenever we write this E and cross it like this, it means not an element. And whenever we write E and we do not cross it, it means it's an element. Alright? So this is it about question number 2. So please stay tuned. We are going to see number 3 part of this question.